Hello everyone. Continuing with the chapter Environment and Health in the subject Health Education and Community Pharmacy. Last time we have started with the first environmental factor, that is water, isn't it? So regarding water, important functions we know. We have seen about the water pollution, isn't it? What is the definition? What are the causes? Isn't it? Harmful effects of water pollution, prevention of water pollution, isn't it? Sources of water, isn't it? So that is also important part that we have seen. Continuing with this factor water, in this today we will see purification of water on large scale. Now, water is purified on large scale for supply to a city or town, isn't it? So, whatever the water we get through the municipal corporation at our home, isn't it? So, that is purified water, and on large scale, they have to purify. Now, in purification, there are three steps when we have to purify water on large scale. So, three steps are to be followed, and in this, first is storage, second is filtration, and third is disinfection. But in some books, you will find the name chlorination. So, it is one and the same, disinfection or chlorination, isn't it? First step is storage, second filtration, and third disinfection, isn't it? Now in purification on large scale, the two methods are followed, but those when we will talk about the filtration, at that time we will discuss, isn't it? Now how water is stored, that we will see now, isn't it? Now the storage is carried out, isn't it, in the large open reservoirs, isn't it? Or they are also called settling tanks, isn't it? In these settling tanks, the water is stored for 1 to 2 days, isn't it? So, just on physical storage, 90% of the suspended impurities they settle down in 24 hours by gravity, isn't it? And the water becomes clearer, and turbidity of water is also removed. This allows penetration of light and reduces the work of filters, isn't it? So at the time of filtration, it will be much more easier, isn't it? Then certain chemical changes also take place when we store water for 24 hours or 48 hours, we can say, for example. So physical changes also take place and chemical changes. Now what chemical changes will take place? Like whatever the harmful germs are present, they are destroyed naturally, isn't it? Whatever the microorganisms are there, they decrease, isn't it? Then the aerobic bacteria that gets oxidized, that oxidizes organic matter, isn't it? That is present in water with the aid of dissolved oxygen, isn't it? And as the result, the content of free ammonia is also reduced, isn't it? And it rises, nitrates are increased. Then biological changes that take place during storage of water, that is the tremendous drop takes place in bacterial count, isn't it? During storage, pathogenic microbes are destroyed, as I said earlier, isn't it? And when water is stored, like if river water is there, isn't it? So bacterial count also decreases, isn't it? These are the important benefits of storage, isn't it? Then next step after storage is filtration. And as I said, in filtration there are two types of filters. Slow sand filtration, it is also called biological filter, and second is rapid sand filter, which is also called mechanical filter, isn't it? So here the question in this lecture, I will let you know that the question that is asked is on slow sand filter also as well as rapid sand filter also, and in both the cases diagram is very important, isn't it? So you must listen this carefully. The second step is filtration, isn't it? And during filtration what happens, the 99% bacteria they are removed, isn't it? And whatever the stored water is there in storage tanks, isn't it, that is clarified water, isn't it? So that is directed into these large filters, isn't it? First, we will discuss slow sand filter, that is biological filter, isn't it? Now, these are cheap and easy to design, isn't it? They require less space as compared to rapid sand filter, isn't it? The little bit in short, you must know the history about this slow sand filter. That it was developed in 1804 in Scotland, isn't it? And in 19th century, their use has been started, and even today they are generally accepted as standard method of water purification. This is the diagram of slow sand filter, isn't it? The filter beds are watertight rectangular tanks. They are made up of concrete, isn't it? And they are arranged side by side and generally kept open, isn't it? The size of tank depends upon the requirement of water to be supplied to the community. These filter beds they are 2.5 to 4 meter deep, isn't it? And there are different layers which play important role in filtration, isn't it? So you can refer this figure also, isn't it, which is showing the different layers. So colorful diagram you can see which shows different layers of the fine sand, coarse gravel, isn't it? Now these layers are very important that you must try to understand, isn't it? Same thing you can see in this another figure also, the different layers. Now we will start from the lowest layer, isn't it? From bottom to upward. The lowest layer, that is of gravel, or that is also called coarse gravel, isn't it? Broken stones we can call. So the size of this layer is 4 centimeter. Above this layer there is fine gravel. You can see this. The fine gravel total thickness is 15 to 30 centimeter. Then the third layer above fine gravel is of coarse sand, isn't it? The thickness of this coarse sand is again 15 to 30 centimeter. The gravel layer supports or that gives support to the sand layer. The fourth layer above the coarse sand layer is of fine sand. Now the thickness of this fine sand is maximum. This is near about 60 to 90 centimeter. As the particles of sand are very small and large in number, they provide large surface area for water to pass through, isn't it? So here the mechanical straining takes place, oxidation takes place, sedimentation and removal of bacteria also take place, isn't it? So the water on this top of this filter sand, fine sand, there will be layer of clarified water from settling tank, isn't it? That will be near about 1.5 to 2 meters height in height, isn't it? The inlet of water is controlled by the walls. So through walls, the water will enter inside this filter bed, isn't it? And at the bottom of the bed, there are number of perforated pipes which are fitted to collect the filter water, isn't it? So from the bottom, the pipes are there. You can see uh, filtered outflow, isn't it? So from the bottom the filtered water can be collected through this the perforated pipe, isn't it? So this is the design of filter bed. When question is asked on slow sand method, you have to draw this figure correctly, isn't it? Now, whatever these layers are there, all these layers are very important, isn't it? They play important role in filtration process, isn't it? Now, there is one more important thing here, that vital layer is formed at the surface of this filter sand. So as the water will get filtered, a thin green slimy gelatinous layer will get formed, isn't it? Which consists of plant and animal life, isn't it? So this vital layer that is formed, that is called ripening of the filter bed, isn't it? Now this layer that is formed, that increases the efficiency of filtration, isn't it? So as the water gets filtered, this vital layer also will go on increasing in thickness day by day, isn't it? And as the thickness of this vital layer goes on increasing, then the filtration rate will go on decreasing, isn't it? So after few months, we can say, for example, when thickness increases of this vital layer to great extent, like 4 feet for example, at that time what will happen? The efficiency of filtration will greatly reduce, and at that time filtration is uh, stopped, isn't it? Then cleaning of filter is done, isn't it? For cleaning, the top sand layer is scraped off, isn't it? And this process of cleaning the filter is repeated periodically. It may be once in a 6 months, isn't it? For example, because the water that is supplied to the community, so continuously filtration is going on. So at a period of 4 to 6 months, the cleaning of filter bed is required, isn't it? So that is the construction and working of this slow sand filter. Advantages we must know about this slow sand filtration, that it is simple to construct and operate. The cost of construction is cheaper as compared to rapid sand filter. Then physical, chemical and bacteriological quality of filter water is very high. It will reduce total count, bacterial count rather, by 99.99% and Escherichia coli by 99.9%. Then next in this is rapid sand filter, that is the mechanical method. Now separate question is asked on rapid sand filter, isn't it? So here the 5 steps are important, that also we will discuss. And here instead of diagram, flow chart is asked. So how you have to draw this flow chart, that also I will let you know. Now rapid sand filter, this was introduced in 1885, isn't it, in USA. Then it has considerably got popularity, and still it is commonly used, isn't it? Now there are different types of rapid sand filters. Just as an example, you must know two types, that is the gravity type, that is Patterson's filter, and pressure type, that is called Candy's filter. Both these types are in use, isn't it? And there are, as I said, 5 steps involved in purification of water by rapid sand filter. So here, before discussing in detail, I will give you name of 5 steps, namely coagulation, mixing, flocculation, sedimentation, and filtration. These 5 steps you have to explain, as well as if flow chart you are drawing, if it is asked question, So in those flow chart also you have to show these 5 steps only. Again I repeat, these 5 steps are coagulation, mixing, flocculation, sedimentation and filtration. Now coagulation, that is, the raw water is first treated with a chemical coagulant such as alum. Alum meaning turti. You might be knowing, isn't it? It is used at home for purifying water, isn't it? So the dose of alum varies from 5 to 40 milligram or more, isn't it, per liter, depending upon the turbidity, that how the water is turbid, isn't it, depending upon the color, depending upon the temperature and pH. So accordingly the range is given, that how much quantity you have to take of alum per liter water. It is 5 to 40 milligram per liter, isn't it? Then second step is mixing. Now the alum treated water is then mixed mechanically in a mixing chamber, isn't it? So whatever this treated water is there, the water that is mixed with alum, that is then subjected to mixing chamber for few minutes. And in this mixing chamber what will happen? Whatever the alum is there, that will get dissolved in water, and whatever impurities are there, that get precipitated, isn't it? Then the third step is flocculation. From mixing chamber, the water is subjected to flocculation chamber, where the water is stirred, mixed, or gently we can say stirred at a slow speed. We can say the speed is very slow, for near about half an hour it is done. And in this period what will happen, ki mechanical type of flocculation is done, isn't it? So a flocculation chamber is there in which the water is subjected, where the water get mixed, and this flocculation chamber is consist of the paddles which rotate at 2 to 4 rounds per minute, isn't it, with the help of motor, isn't it? It results in formation of thick copious white flocculant precipitate of aluminum hydroxide. The thicker the precipitate or floc diameter, the greater the setting velocity will be there. So that is the third step, that is called flocculation. The next is sedimentation. Now the coagulated water is now directed into sedimentation tank, where it is detained for period varying from 2 to 6 hours, isn't it? So in this settling tank also we can call, here the water will remain for a period of 2 to 6 hours. During this period what will happen, the precipitate along with suspended matter and bacteria settle at the bottom, isn't it? And whatever supernatant water is there, that looks very much clear in appearance, isn't it? The flocculated material from the settling tank is removed from below, isn't it? So here also at least 90%, 95% of the flocculant precipitate, they get removed, isn't it, before water is admitted into rapids and filter, isn't it? So the precipitate or sludge that is formed, isn't it, that forms settles at the bottom, that is removed from time to time from downward only. So at the bottom there are perforated pipes, through that these whatever the flocculated material is there, that is removed, isn't it? So from the bottom when it is removed, so that will not disturb the operation of the tank, isn't it? Now that is about the sedimentation, given that for proper maintenance tank should be cleaned regularly, isn't it? Then fifth step is the filtration, isn't it? So This is the important fifth step. Whatever the clarified water is there in the rapid sand filter, it is directed where we get 99% purified water. Now, advantages of rapid sand filter. So, this can deal with raw water directly. There is no preliminary storage required as in case of slow sand filter we have seen, isn't it? The filter bed occupies less space, isn't it? So if we compare with slow sand filter, there slow sand filter occupies more space, the rapid sand filter occupies less space. Then the cost is low in case of slow sand filter, where here in case of rapid sand filter the initial cost is high, isn't it? Filtration is rapid, it can be 40 to 50 times that of slow sand filter. Then washing of filter in case of rapid sand filter is very easy, isn't it? So these are certain important advantages of rapid sand filter. Then this is about the flow chart of rapid sand filter. As I said, the question many a times is asked only on draw a flow chart of rapid sand filter. So here, as you can see, it is very easy, and you have to just show these 5 steps that we have discussed in rapid sand filter, isn't it? Namely, uh, coagulation, mixing, flocculation, sedimentation and filtration, isn't it? So here also, first you will see that from the source of the water, that is river water, alum is mixed depending upon the quantity of the water, and that water which is mixed with alum, that is subjected to this mixing chamber, isn't it? In mixing chamber, mixing is carried out, then flocculation chamber, then sedimentation tank, isn't it? And then filtration, and after filtration again then chlorination that we are going to discuss now, isn't it? And after that the separate storage tank is there of clear water, from which the water is supplied to the community, isn't it? So to the towns, to the villages, whatever the water is supplied, that is through these storage tanks in which the clear water is stored, isn't it? So that is about the flow chart diagram. Then the third step, that is we can call disinfection, or also we can call chlorination, isn't it? Now this chlorination is the last step, isn't it? It is required for sterilization of water, isn't it? Now here, this due to chlorination, whatever the harmful microorganisms are there, if they are present, they are destroyed, isn't it? And water becomes safe for drinking, isn't it? And as the word indicates chlorination, so some chlorine containing compound is used. Here some examples as they are given, like chlorine gas, chloramine, perchlorone, isn't it? So chlorine gas is the first choice, isn't it? Because it is cheap, quick in action, easily available, and it can be easily applied, isn't it? The only thing is that chlorine gas is irritant, isn't it? So eyes are to be protected, isn't it? Also its quantity may not increase, isn't it? Because it is poisonous also, isn't it? Now, so these are some of the examples of chlorine containing compounds. Chlorine can be used in the form of gas or solution, or in the form of bleaching powder also, isn't it? So chlorine gas is used mainly, isn't it? Now when chlorination is done, isn't it? So it must be ensured that the water must be clearer, it must not be a turbid one, isn't it? Because in turbid water, chlorination is not effective. Now, how in chlorination exactly what happens, we will see about the mechanism also, isn't it? These are certain actions. Before talking about mechanism, we will see that what action takes place. As I gave you idea also that because of chlorination, all pathogenic bacteria they are destroyed, isn't it? Then chlorination oxidizes iron, manganese and hydrogen sulfide also. It reduces taste and odor. It controls algae and it maintains residual disinfection. So these are actions that are taken by the chlorine compound, isn't it? This is mechanism of action, that exactly when water is mixed with chlorine compound, so what action takes place? What is the mechanism? Now the chemical action of chlorine with water is due to formation of hypochlorous acid. So in first reaction you will see that there is formation of hypochlorous acid, that is HOCl. HOCl is hypochlorous acid, isn't it? And hypochlorite, that is in the second reaction, that is OCl, isn't it? So the germicidal action of chlorine is taking place at pH 7, isn't it? So when this hypochlorous acid and hypochlorite are formed, then and then only the whatever the bacteria are there, germs are there, they are destroyed, isn't it? And whatever the oxidizing activity or the step that is resulted only when there is formation of hypochlorous and hypochlorite, isn't it? So that is all about the water. Here, the purification of water on large scale we have completed, isn't it? The small scale purification also we will discuss later on, isn't it? Go through this slide. If you're not understanding, so listen twice, thrice, isn't it? Thank you.